I'm very glad to present a cognitive application on diabetes diagnosis to JK Hospital stakeholders. Um, this application is a solution based on IBM Watson services on cloud. Okay, here is the outline of today's presentation. First, introduce the use case and the business requirements. This followed by the apply the design thinking and agile process, which is what kind of methodology we are going to take. And then followed by the architecture overview, architecture decisions, and user experience. Then we will walk through the project step by step. And three different steps, basically, they are build the models, deploy the models, and apply the models. And finally, we will talk about the plan of the future iterations. Okay, let's go through the what kind of the method we are going to use. We are going to adopt the very typical design thinking, lean startup, and agile, combine them together. And we will get a very quick inception phase, like a couple of weeks. From January 1st to January 18, we are intake the requirements and get to the training data set, which in this situation is the diabetes data set. And also plan the several architecture decisions, including what kind of environment or system is going to be used, what kind of model is going to be, candidate models is going to be used, and also how the final application looks like when we put together. And then we quickly jump into the lean startup, which is a complete end-to-end solution prototype. Which is runnable prototype, and including the build model, deploy model, and apply the model to our node-RED application chatbot. In the future plan, and we are going to keep the iteration going on to enhance the model and enhance the application, and also extend the application to the other areas beyond the diabetes. Okay, let's see the use case and the business requirements. Business requirements very straightforward, and based on the JK Hospital's requirements, is to based on the historic diabetics diagnosis data to create a diabetes prediction model, which provides a prediction for the patients who are likely to develop diabetes with 70% or higher accuracy. So initially we get 70%, but with the iteration move forward, we will expect the accuracy will improve, and it could be 80% or 90% based on the future iterations. So that there are three different steps, or it's kind of the use case scenarios. We build the model, deploy the model, and apply the model. They all were covered in today's presentation. Okay, so this slide includes the end-to-end pipeline or architecture. Three different components. The big components, first is the build of the model, including the multiple steps starting from the data, CSV data loaded to the cloud object storage, and then go through the ETL, EDA, and separate to the label and the features. And after training the models, and we validate and select the model with the best accuracy, and publish that model to the Watson machine learning. And when we after publish and deploy it, we can expose the URL of the API so that we our cognitive chatbot can access the API and working with the Watson assistant conversation. So then we can develop the chatbot. So now let's take a quick look at the user experience. The user experience, depending on the features, the key features of which is relevant to the diabetes, including the pregnancy, the glucose, and blood pressure, skin thickness, or the BMI, insulin, age, whatsoever, and the final results, we will get the probability of the non-diabetes and diabetes probability. So I do have a live demo here, which use the Slackbot, and then we can take a look how it looks like. Overall, this is kind of the prototyping. So it's check diabetes. When I type the check diabetes, and then system is going to reply, okay, ask a few questions. Okay, so now we just input the one by one with the numbers system required. What is glucose number? 100. Blood pressure 100. BMI. The age 35. So then, system percent and 32% and 35% is going to be maybe you have diabetes. So there are certain risks there. So you can see it using this kind of method, we can get the probability. So patient is going to know, not just a simple answer yes or no. It's kind of the how much closer to the diabetes. Okay, now after we see the user experience, and we will quickly move forward to work through the implementation. Implementation including the build model and the deploy model and apply the model. So we will focus on the Jupyter Notebook in the Watson Studio. Okay, this is the notebook we are going to review. So in the notebook, and as you can see, there are 3 different parts. And firstly, using the supervised learning and the non-supervised learning, and we were pipeline the based model. We selected with the based accuracy and go through the deployment to the machine learning. And so now, supervised learning, and this is the original data. And then after the ETL and the EDA, and then we just try to eliminate the results, eliminate the like duplicate data, and also impute the data with the 0 values, and do some analyze of the data to see, like 65% versus the 35%, and then we quickly apply the model to the accuracy. As you can see, the random forest give the better accuracy probably than most of the others. For example, naive Bayes is get 0.73, and also some of them get 6 point something. So and the random forest, so it's going to be used as the following things. And meanwhile, I did some work on the non-supervised learning and the neural network, feed-forward neural network, do some kind of working, even though this is typical classification process. I still do some job in case in the future it do make more sense go through the clustering, which is non-supervised supervised learning path. So this is kind of starting point. We get the 100 EPCOs and then compare with the different models. And in the end, the accuracy is also not bad, but 80%. And but however, the problem is if you see that there have some overfitting problem, and also this is probably much easier and much more convenient to using the typical classification. So then we followed by choosing the random forest supervised learning and random forest classification, and then we go through using the Spark and then do the pipeline. And after that, we are try to publish the model to the Watson machine learning, and after publish the model to the machine learning, and then we deploy the model, and so that the external URL can be accessible as externally. So here is a scoring URL, and then we just use this URL put to our application. Okay, So in the end, and we do some tests in the Jupyter Notebook and using some test data. First one is yes, this is diabetes, and the second one is no. Mostly do not have diabetes. Okay, so after this, we can take a very quick look of how can I build the very quick, rapidly build the cognitive application. So the application is using the Node-RED, and Node-RED using both Watson Assistant and also have a web service call to the to the diabetes model in the machine learning, Watson machine learning. So based on both of the results, as we can see, we can get the probability of the final results we just called. Now, I think this conclude my this not yet, and after that, okay, this is the kind of user experience for the application introduction, and the last page is going to be the future iteration. Future iteration, we will focus on enhance the model first of all, right? We will keep adjust the features and weights to pursue the high accuracy, and maybe there is one key important thing is we need to load more data. So for the first iteration, we only have about 800 data. In the future, we get more data, can get more beta accuracy, and enhance the application, enhance the user interface, enhance the scalability performance, and ensure the security. And also we can extend this model almost exactly the same to the other predictions. For example, predicting the cancer or predicting the heart failure diagnosis, etc. So, so this concludes my quick introduction of the inception and the first iteration of the machine learning on the diabetes diagnosis project. Thank you.